So you've just started AP Calculus AB or BC, and you are just beginning to understand what calculus is. So the key question in calculus is to answer this idea. Can change occur at an instant? Calculus is the study of change, and through this first unit, limits and continuity, you're going to understand exactly what that means. Now, as we get started here with topic 1.1, introducing calculus, can change occur at an instant, we're going to look at something called the limit. So you may have seen the limit notated like this. It should be LIM as x approaches some value, let's call this value c, just a number c, any number c, of f of x. And what is this equal to? Well, the limit is as you approach, as you get infinitely close to this value c, that is the limit of the function at c. So let's say we have this simple graph here, y equals x squared, and we're trying to find the limit of x squared as x gets to 4, right? So we're looking at the value 4, so c is equal to 4. So as we get infinitely close, what is the y value that this function will produce? Well, we know, obviously, that when we plug in x squared and we have 4 squared, we're going to get 16. So it might lead you to think that this is 16. And you would be correct. The limit as x approaches 4 of x squared is equal to 16. But what if our graph looked something like this? What if we have your normal x squared graph, but then there's a removable discontinuity. There's a hole in the graph right at x equals 4. And for this function, which is no longer x squared, so f of x is not equal to x squared. All right, it's not equal. Let's say we had that function and it is defined at x equals 4 to be 20, instead of 16. Well, what is the limit? Now, like I said before, we're getting infinitely close to this limit. We are getting infinitely close to the point x equals 4. And if we take a look at this table here, as we get infinitely close, as this value here, this x value, gets closer and closer to x equals 4, we still approach the number 16. All right? We start from 16.8, get to 16.08. We start from 15.21, we go to 15.92. And we could continue this to say 3.99999 and going on forever. As long as it's not exactly 4, we can still see that these values will get closer and closer and infinitely closer to 16.0, right? And so the limit here is still 16. All right? And so that's one important thing that we need to know is, can change occur at an instant? And that's at this instant 4 that, true, it's not defined to be 16, but the limit as we get infinitely closer is 16. Now, one last thing that the College Board wants you to know is what's happening here. So this is a line where our independent variable has no change at all, right? It's just x equals 3. Now, there is no instantaneous change happening here because the independent variable is not being manipulated. We are not having a function. The graph is not going like this or like this, right? It's only at one point. It's only defined at one thing, x equals 3. So if we had that same idea, if we had like x equals 2.999, well, the function is not even defined there. All right, and there's no instantaneous change going on here. So that's all you need to know for topic 1.1, limits and continuity. We'll see you guys in the next video, topic 1.2.